Dear students, welcome to my channel. Today I am going to explain about the referencing operator and dereferencing operator. Referencing operator is also called address of operator and dereferencing operator is called indirection operator. We'll see that example. I have declared two variables int I and int j, and in the previous video I have already told that if it is declaration, if you declare the int I, so whatever the size of int, that much space is going to allocate in the memory, and wherever the space it is, there will be the some address. Wherever you are allocating the space, there will be some address, right? So similar like that, the another variable is j. If you are declaring the j, whatever the data type, that much space is going to allocate, and that space will be the some address. That space will be some address. If you relate with the real life example, suppose a person is the Ram is the person, and Ram is staying somewhere. Wherever the Ram is staying, that have some address. So suppose the Ram friend wants to visit the Ram friend wants to visit the Ram. If they know the Ram's address, then only can visit. If they know the Ram's address, then only they can visit. Otherwise they cannot visit. That's not possible without address to visit, right? So similar like here, I is allocated this space and I address is this one. If j wants to, yeah, some other person want to visit the I, if they know the address of the I, then only they can visit. Otherwise they not visit. It's not possible to visit if they don't know the address, because there is a big memory. If you say that big memory, in the real life you say that there is a big world and there are many people are staying, and if we want to visit a single person, we need to know the address of that person, then only we can visit, right? So address will tell you that where this person is staying, then only you can visit that. So here also, suppose you have a 2 terabyte of the memory. In that 2 terabyte of the memory, where this I is stored, where this I is allocated the space, and this address will tell that this I is allocated at 1000 address. Similar like that, this address 2000 will tell that j is stored at this address. J's address is 2000, I address is 1000, right? Now I will assign the value, means I equal to 10. This is called initialization. I am saying that I value is 10. I value is 10. So this 10 is going to store at that address. Wherever this I space is allocated, there this 10 is going to store, right? And if I am saying that j equal to 30, so wherever the j is allocated a space in the memory, the 30 is going to store there. So 30 is going to store there. Now another declaration, this is pointer declaration. This was the normal variable declaration, this is the pointer variable declaration. Process is same for the pointer variable declaration also. While declaring whatever the size of this data type of the p pointer, it is also going to allocate a space in the memory. So in this line, p is going to allocate space in the memory, and p will also get some address. Q will also going to allocate the space in the memory, and q will also get some address. Right? See, this part is empty. I haven't written anything because just I have declared. In real life you say that you just purchased a place. You haven't started staying. You just purchased the land. You haven't started staying. So while purchasing the land, there will be some address. Means you purchased in the Delhi. Then you can say that Delhi is the address. Right? So similar like here, p is just allocated the space in the memory and he got address. Q is allocated in the memory and q got address, right? Now what we will do, and one more thing before coming here, I'll explain here. For the pointer all data type, Pointer size for all data type, either integer, either character, either double, float, string, whatever the type, either as array, for all the pointer data type. If it is your microprocessor is 64 bit, all size is 8 byte only. So for pointer size for every data type is always same, and that to depend on what? Microprocessor size. If it is a microprocessor size is 32 bit, so for all this pointer, all the data type pointer, even your integer pointer, that's also going to allocate 8 byte. Float pointer allocate 8 byte. Pointer array, that will also going to allocate 8 byte. Pointer function, that also going to allocate 8 byte only. So that size is fixed for all data type, for the only for the pointer, only for the pointer. But for the other variable, that is vary. Integer size, if it is your microprocessor size is 64 bit, then integer size is 4 byte. Float is also 4 byte, double is 8 byte. But if your microprocessor is 32 bit na, then integer size will be only 2 byte, and float size is also 2 byte, and double is 4 byte. Double is 4 byte. Right? So do remember this. If you understand this, you can easily understand this one also, how the space size of the pointer are normal. Okay, so now coming to this part, coming to the address of operator. This is called address of operator. Now what P is saying that, what this line is saying that P equal to address of I. What is the address of I? What is the address of I? Address of I is 1000. So 1000 is going to store in the P. 1000 is going to store in the P. So where is the P? P just purchased the place, but they haven't started staying. Now P got the address of I. Now P is going to store address of I. And what is the address? 1000. So 1000 is going to store. Now P, see till here P is pointing to I. P is pointing to I. In this line P is pointing to I, means you can, and P is nothing but a pointer. P is nothing but a pointer, right? It means that here, it means that P is pointing to the address of I. Next statement is saying that, one more thing before going to the next statement. Here what it is saying that P equal to saying the address of I. Now if you want to access this value, if you want to access this 10 using P, using pointer, if you want the access to the I, then how will you access? Because we were learning here dereferencing operator, that is nothing but a star. Then if you want to access this 10 using pointer, you have to access only with that, only with the star, star P. If you want to access the I value, you have to write it there. Here you have to write star P, then you will also get that value 10, right? You can access the I value using P. That how can you access? You will write the star P, it will also going to give you that value is 10. Either you print I, either you print star P, you will get the value is 10, right? Right? So for till this line, if I am going to here print, if I am going to print here P star P, it will return me what? It will return me 10, right? Now next what it is saying that? Next is saying that P equal to address of J. P equal to address of J. So what is the address of J? J address is 2000. And now saying that P equal to 2000, you have to assign to P, right? So previously P was staying 1000. Now is saying that now assign J's address, not to I address. So now what will you do? You remove this 1000 and store what? This line is telling that to store 2000. You have to store now 2000. So while storing this 2000, this connection will delete it. This connection will deleted, and now the new connection is formed, and new connection is nothing but a P is going to point to J. P is going to point to J, and if you print this P after this line, you will get value is what? You will get value is here 30. You will get value is here 30. Right? See the difference. Right? See the difference. Now P is pointing to here, and P, previously P star was there, now this P star also shifted to here. Now P star shifted here. If you want to here print star P, it will going to give you 30, not to 10, because now P is storing the address of J, not I. So do remember that. Right? Next pointer is my Q. Next pointer is my Q, and there I am storing the address of J. So what is the address of J? Address of J is 2000. So now 2000 is going to store in the Q. So Q is going to get that 2000. We are going to store the address of Q. So here now the new connection form is that. Now new connection is going to form that the Q is going to allocate J. Q is going to allocate J. Right? Now if you want to print here, dereferencing operator with Q, what it will going to print? Because Q is just taking the address of J, and what is the J value? 30. If I write here address of, if I am going to write here address of Q, it will going to print address of Q. If I am going to write address of Q, it will going to print 6000. If I am going to print here, print star Q, it will going to return 30. If I am going to print here J, it will going to print also 30. If I am going to print here address of J here, if I am going to print here address of J, then what it will print? Address of J, it will going to print address of J, and that too 2000. Right? So either you are writing star Q, you are getting 30. Either you are writing J, you are getting 30. Either you are writing star P, that's also giving you 30. Right? So here 2 pointer is pointing to the single variable. Because of that reason, either you are printing star Q or star P or J, all three cases giving you 30. Right? Next one is that is very much important, is that the very much important question is that here, if you write P equal to, in the single line, if you give that P equal to address of I, comma address of J. If you write P equal to address of, there was a single assignment. P is storing the address of I, but here they are saying that P is equal to address of I as well as comma address of J. In this situation, you just check that priority of the operator. This equal is called assignment operator, and this is comma operator. So check that the priority table, which operator is having the highest priority. That operation performed first. Which operator is having the highest priority, that operation is performed first. So if you see that the priority table, there is a already defined priority table. If you check that, then you will see that the equal operator is having the highest priority than comma operator. Equal operator is having highest priority than comma operator. So whatever the address of I, that is going to assign to P. Whatever the address of the I, that is going to assign to the P. So here the P value is 1000. Here the P value is 1000. Right? So do remember, here P value is 1000, not to 2000. Here we are only going to perform this operation. Right? Because equal operator is having highest priority. Same thing, if I put that bracket, and if you see that the priority table, then bracket is having highest priority. So first you have to perform the bracket operation. So what will you do? Here what happened? This will going to exclude, and there P's value is going to store address of here. Sorry, it's not I. It's a G. Right? So here the P value address is nothing but 2000. This is very much important for the placement technical round. In the technical round, this type of the question will come. They will give you this, and they will give you option like P equal to 1000, P equal to 2000, and P equal to 1000 as well as 2000, and fourth option is that none of this. So this type of the question will come in the placement procedure, technical field. The technical round, when the first round was the technical round, in technical round they will give you this statement, and they will ask you that which option is correct. First option is that 1000, P equal to 1000. Second option is that P equal to 2000. Third option that P equal to 1000 and 2000. And fourth option is none of the above. Now tell me what is the P value. So please try to understand this. The value is P equal to 1000, or for this case P equal to 2000. So do remember, this is very much important. So I am writing here VVL. It means that very much important. Okay. Next we'll see. Next is I have just created that priority table. Just now I said that no? Priority table, the equal operator is highest priority than comma operator. See, the lowest part it means that this is having the least priority, and this upper one is having the highest priority. And the lower part is having the low priority, right? And bracket is having the highest priority, even for the even the equal also, as compared to equal assignment operator. Bracket is having the highest priority. Now, right now we'll see that the implementation, the example I have given here, how you are getting this value 1000, this one and this one. All these I am going to now implement on online compiler, and then I'll show you that output. So this is my online C compiler. Now I'm going to write the code for that pointer and for accessing that element. So this is my format already given. Now I'll write it here int I, and I am giving that I value is 10 and j equal to 20 or 30. You want to give that 30? Okay, 30 I am giving, and I am going to another variable. I am going to declare that pointer int p comma and q. I have a 2 pointer, right? Now what will I do? I am going to write it here. P equal to what I will write? P equal to address of I, right? Now I am going to print here. What I am going to print here? I am going to print here print I. I am going to also print I, j, as well as I'll show you first. I'm going to print here first I and j. I'll give you a space, so it will going to print in the space, and then third one I'm going to print what? Just I'm printing I and star p. So I, and if I'm going to print here star p, then I'm going to just simply run that code. Please try to see that output. Here I first stage I come, and next stage a star p come, and run this code. What value it will going to print? Have I done some mistake? Yes, it's a printf. So if you run this code, oh, semicolon I missed. If you run this code, you will get here, you will get that here 10 10. I value is also 10 and star p is also 10, right? If I am going to print here p, so p is containing what? P is containing what? Address of I. So if you want to print the address, the percent and d will not going to work. For the address, printing the address, you have to use percent sign u. Percent sign u. So if you print here p, normal p, you see that address of the p. Address of the p is what? What is giving error? 1 minute. If you run that, you will get the some address. It's giving the address. Look at that. This is giving the address, but warning is giving. What warning it's giving? That warning format that percent sign u expect argument of the unsigned int. Okay, I'll put it that p. We'll see that what output is giving. See, sometimes what happens, they are taking that percent sign p, and sometimes it's taking percent sign u. Do remember, whenever you are going to print that address, whenever you want to print the address, then sometimes it will work percent sign p and sometimes it will work percent sign u. We'll see one more thing here and then it will going to clear it out. I'll print here address of I also. Here address of I also I am going to print, and for that if I am writing percent sign p, we'll see what it will do. Will it give you warning or simple output? So here is working as a percent sign p, working as a address. So do remember, whenever you are going to print the address, see, and don't forget that sometimes percent sign p will work, sometimes percent sign u will work. So I have so do remember that if it is you get that warning for the percent sign p, use percent sign u. If you get sometimes a warning for the percent sign u, then use p. Like that you do it. Okay. Now this is for the p, right? Now I am going to assign here after this printing I am going to assign that p equal to address of j. P equal to address of j, and same process whatever I have printed here, again I am going to print here, and we'll see the difference. Just try to understand and give that more space. So for the better understanding I am giving more space so you can easily understand that. For here also I am giving that more space so you can easily understand. So now I am going to run that code. Okay. See, try to observe once. One more thing I need to add here, percent sign in, so you can, it will going to print in the new line. Okay. Now I'm running that code. Oh, sorry, network connection problem. So look at that. Try to observe that. Try to observe it. So this address of I, D8 is the address of I, and what it is doing that here, this is also address of I, this is also address of Y, but the P address is changed. So better to print that I am going to print that here J, because I have mentioned that address of J, so I am going to mention that J here, right? So I am going to mention that J here and star P and P. Now I'll run so you can easily understand. Look at that. The star P is giving what? 30. Star P is giving 30. Right? Earlier the star P is giving what? 10. Look at the code. Here also I am printing a star P. Here also I am printing a star P. But before this statement of the statement, this star P was 10, and after this statement star P is become now 30, because now P is pointing to the address of J. Previously P is pointing to the address of I. Okay. Now we'll do the Now I'll do that q pointer. I'm going to assign the q pointer address of j, right? Now if I'm going to print here, if I'm going to print, sorry, what I'm doing here. If I'm going to here write the printf, and I'm giving the slash n because I want to print in the new line, and I want to print what? I'm going to print here percent and q, sorry, star q. So what it will going to print? What q will going to print here? Q will going to print 30 because q is storing address of j. So whatever the value of the j, that q is going to print, right? You are writing a star, right? If I am going to write only q, if I write only q, what it will going to print? It will print address of j. It will print address of j. So run that. If I am going to print address of, one more thing, if you are printing address, what will you write? You will write p, ampersand, percent sign p, and run it. Run it and try to understand this. So see that what p is printing? P is printing the address of j, and this is what? This is what? This is address of j. This is address of j. So p is printing address of j, right? So for the better understanding, shall I write it here like I? That's no problem. So this is I'll write it here, one more printf statement for the better understanding. This is the address of j, okay, and here I will going to write it here, printf address of j, comma space, and what you are printing? J value, space, sorry, comma, space, p is also printing, star p is also printing. Why I am writing here star p is print j value, and again comma, I am giving a space, and printing that p, address of p, right? So I am going to just saying that not address of p, address of j, that is going to store in the p na, so that will going to print na. So I'll give you the space, so it will going to clearly understandable. Now I am going to run it. Somewhere I missed that semicolon, so that's the reason you are getting error. Again, have I done somewhere mistake? It's a printf. Now I'll run it. Where I have again, why I missed that print? We'll see another. Try to see that. One more thing. Slash n. Here also I am going to put slash n, so it will come in the new line. Now we'll see that output. Look at that. What it is doing that? This is address of j. Right? And this is also address of j. Is it matching? Matching or not? Is this matching or not? Yes, this is matching. This is j value. Star p is also printing j value, because why star p is printing j value? Because now p is storing the address of j. Because of that reason, star p is printing 30, right? And address of j is this one, right? If you write ampersand j, it will going to print address of j, right? So now try to understand here what I am doing. If I am saying that address of I, ampersand, whenever you add ampersand, it means that it will going to print address of I. And if you write I, it means that whatever the I value, that is going to print. And ampersand, sorry, star p, it means that p is storing address of I, P, if you print simple P, it will give you the address of I. If you put it a star before P, if you add star before P, it will give you the value of the address that P is stored. It will give you the value, the P stored the address, means P is storing the address of I. So whatever the I value, that is going to print, right? Similar, same thing I did it here, because now P is storing the address of J. Now P is storing address of J. So if I am going to print star P, here it will give you the star P value, will give you the jth value. If normal, if I print normal P, P will going to print the address of J, right? And if I write add star P, P will going to print J value, right? And if I write address of P, then P will going to print their address, right? So coming to this example here, what I am doing here, if it is you are writing address of P, then Q, then Q address is this one, 6000, then 6000 is printing. If I writing star Q, so check that what Q is storing. Q is storing address of what? Address of J. And you have added a star, it means that J's value is what? 30. So 30 will print, right? And if I simply print J, J will going to print what? 30, right? If I print address of J, it will going to print whatever the address of J, that will going to print. Understood? So this is all about the referencing operator and dereferencing operator, how to access the element using pointer, and how to access the normal. So normal you can easily access, simply print the variable, you will get it. And if you want to access the variable using pointer, then how will you access? So this is the normal accessing for the single pointer. Directly you can get the, directly you just write a star, and whatever the address is storing, that value is going to print. So this is all about the referencing operator as well as dereferencing operator. Thank you for watching my video.